Hello everyone. Apologies for the delay in publishing the assignment. It's almost ready, so it's here. Here it is. This is the draft version. You can access it. You can access it here. So I will post it in the chat. You can have a look at the new assignment, the maths assignment. Yeah, I will publish it tomorrow. Okay, I will definitely publish it tomorrow. Unlikely that I'll be able to do this today. Okay, can you hear me well? Okay, good. So today we're going to do coordinate geometry. So it has two parts. It has a 2D and 3D coordinate geometry. With 2D coordinate geometry, you should be fairly familiar because it's basically straight lines. It is well, it is, but one thing you might not be aware of is how much it is related to vectors. So let's start. Problem 1. Find the equation of a line passing through the point and okay, so that is a typo. It is meant to, well, it's going to be minus 1.5. You see, that is it should have been from the last year's assignment. Okay, minus 1.52, and crossing the x-axis at 45 degrees, measured clockwise from that axis. Okay, so this is a 2D problem, and this should be fairly straightforward. So all you need to do is to draw a decent diagram. So x, y. The problems today are not going to be particularly difficult. You can watch some other webinars on harder problems, but yeah, today it's more on the basic side. So you have a point minus 1.52. So this is minus, let's say this is minus 1. This is minus 1.5. 2, so 1, 2. And crossing the x-axis is if measured clockwise from that axis. Well, that simply means it is 45 degrees to the axis. Well, it must be like this. The interesting thing is that the tangent of that angle, theta, tangent of that angle is the gradient of the line. So tan 45 is 1. Well, of course, the gradient is not 1, it is minus 1, but the angle is not 45 technically, because the angle is this. This is 135 degrees, because you measure angles anti-clockwise. Tan Okay, the assignment, as I said a minute ago or so, the assignment is not published yet. It will be published in maybe 10, 12 hours. This is the assignment. This is the draft. You can access it via the link I posted just above. You can start doing it because the problems will not change. I'm just going to check it for typos and, well, if the problems make sense, because sometimes, yeah, sometimes we make mistakes. So, yeah. So this is the draft version. The problems will stay, so you can start doing it. Does that make sense, Risham? Okay, here's the link. Right, so the angle is 135. So the gradient, well, it's not this angle. Gradient is tangent of that angle. Theta is gradient. Gradient is m, and that is tangent of theta, which is tan 135, and that is -1. But of course, I mean, if you made a mistake and saw that it is 45 and used 45 degrees rather than 135, it's kind of obvious that the gradient of this line is -1. And so the y is equal to -x plus, and you can work out, because if this is -1.51, you can work out that the y-intercept is 0.1/2, and that's the answer. Does that make sense? Any problems here? Any misunderstanding? Quite an obvious problem. I mean, it's not particularly difficult. Okay. No questions. You could write this differently. Sometimes it's written in standard form. So you can write 2x plus 2y is equal to 1. It's another way of writing it. Sometimes it's called standard form. Or it's sometimes written to 2 plus 2y minus 1 equals 0. Another way of writing it. So these are the same thing. Same. Right, let's move on. Another quite easy problem. This is a PAT problem. The points 5, 2 and -3, 8 are at opposite ends of the diameter of a circle. Okay, so we don't really need an accurate diagram here. So for all intensive purposes, -3, 8 and 5, 2. 5, 2, -3, 8. So a sketch is more than enough. So opposite ends at the diameter of a circle. So this is the diameter of a circle. So the midpoint of the diameter is the center of the circle. Let's give it a name. Let's call this A. This is B. And let's call this M. So M has coordinates. We're using the midpoint formula, -3 plus 5 over 2, 8 plus 2 over 2. So M has coordinates 1 and 5. 1, 5. How would we find the radius? The radius of the circle? Yeah, you can use the distance formula, or you can use the modulus of a vector formula. You can find the modulus of the vector MB, because MB is the radius. So you can find MB. Vector MB is equal to, is a column vector, 5 minus 1, that's 4, minus 3, 4 minus 3, and the length of that vector is going to be square root of 4 plus, so 4 squared plus minus 3 squared, and that's going to be 5. So the radius of the circle is 5. And we need the equation of the circle, and we know that the equation of the circle is x minus x0, where squared plus y minus y0 squared equals r squared. That means the equation of the circle is x minus 1 squared plus y minus 5 squared equals 25. Okay. Also, you could make it this is the equation of the circle. You could make it a bit convoluted because sometimes you're given the equation of a circle without these. So it's x squared minus 2x without the brackets plus 1 plus y squared minus 10y plus 25 equals 25. So 25 cancels and we get x squared plus y squared minus 2x minus 10y plus 1 equals 0. So if you see this equation, you see equation like that, you need to be able to work out that this is actually an equation of a circle. Okay. And this is done by completing the square. Any questions so far? Any questions so far? All right, getting to more interesting stuff. A question with a star, problem with a star. Find the length of the angle bisector AM. So here we're going to use everything we know about stuff, about coordinates. Find the length of the angle bisector AM of the triangle ABC. If AB is equal to C, AC is equal to B, and angle A is alpha. Well, ABC, ABC. So it doesn't really matter how we draw it. Just need to start. Okay. So introduce a coordinate system. Where would we put angle, or put A? Well, it's always good to put one of the corners into the beginning, into the origin. And because every piece of information we're given contains A, it would be a very good idea to put A into the origin. You don't have to, but it looks like it's a good choice. You put A into the origin. B, well, what do we know about B? We know AB is C. Okay, so B is here. We don't know where B is. And C, let's put it somewhere here. Make sure that the triangle is scalene, so it doesn't, we don't get tricked by and somebody asks you to draw a triangle, don't draw an isosceles triangle and don't draw an equilateral triangle because nobody said, well, you understand what I mean. Okay, so what do we know? We know that AB is C, so this side is equal to C. And AC is B. Okay. So that means, well, A has coordinates 0, 0. This angle is alpha. So what are the coordinates of point? Okay, let's say what are the coordinates of point C? Starts with the easy one. What are the coordinates of point C? B0. Very good. What are the coordinates of point B? Very good. Agustia, C cos alpha, C sine alpha, not 0. C cos alpha and C multiplied by sine alpha. So this is the coordinate of point B. Okay. Then what we need is we need the angle bisector of angle A. So AM is a bisector. M. So we need to find point M. Okay. Right. So we can, first of all, we're going to use the equation of a straight line passing through 2 points. Equation of a straight line passing through 2 given points. So this is x minus x1. What am I doing? Y minus y1 divided by x minus x1 is equal to x2 minus x1. Sorry, y2 minus y1 divided by x2 minus x1. Is everyone are you familiar with this formula? Oh, lovely. So line BC has equation y minus 0 divided by x minus b equals c sine alpha minus 0 c cos alpha minus b. Okay, can we do something about it? Well, y equals c sine alpha, c cos alpha minus b multiplied by x minus b. I'm going to keep it like this. I don't want to overcomplicate it. This is an equation of a line. This equation of line BC. Line BC. Is everyone on board so far? Is there do you understand what I did? I found the equation of line BC. It is in terms of C and alpha and B, but it's an equation. Oh, because when we say bisector of a triangle, we mean a line connecting a vertex and the opposite side. Length bisector of a triangle, by definition, bisector of a triangle. So when you have a triangle, it goes like this. It's the same angle, alpha, alpha. Now we want the equation of line AM. Well, AM has tangent, has gradient, tan alpha over 2, right? Because that's how because the angle for AM is alpha over 2 by definition of the bisector. It's half the angle. So great, and then it goes through the origin, so it has a y-intercept of 0. So equation of AM is y equals tan alpha over 2 multiplied by x. This is the equation of AM. So we need to find where the two lines intersect. So AM intersects BC. So M is the intersection of AM and BC. So that means we need to solve simultaneous equations. And I'm looking for an easy way to do it. Can't see an easy way, unfortunately. So we have to just equate them. So tan alpha over 2 multiplied by x has to equal to c sine alpha, c cos alpha minus b, x minus b. What can I do here? Not much. In this case, I just close my eyes, simplify it, and hope for the best, honestly. Okay, so start doing algebra. So tan alpha over 2 multiplied by x. Multiply. So I'm multiplying both sides by c cos alpha minus b. So to get rid of the denominator, as you would normally do, times c multiplied by cos alpha minus tan alpha over 2 multiplied by x multiplied by b equals c sine alpha x minus c sine alpha b. Okay. It's actually not too bad. Now everything with x goes to one side. Everything without x goes to the other side. So we have x, so tan alpha over 2 multiplied by x multiplied by c cos alpha minus tan alpha over 2 multiplied by x multiplied by b plus minus c sine alpha multiplied by x equals minus c sine alpha multiplied by b. Now x, open bracket, c cos alpha tan alpha over 2 minus b tan alpha over 2 minus c sine alpha, close bracket, equals minus bc sine alpha. Can we simplify that? Well, let's see. Cos alpha can be written as cos squared alpha over 2 minus sine squared alpha over 2. And sine alpha can be written as 2 sine alpha over 2 cos alpha over 2. So that means that x multiplied by c multiplied by, does that actually help us? Sine alpha cos alpha, sine alpha over 2, sine alpha over 2. Okay, as I said, close our eyes and hope for the best. I'm not going to do anything with cos alpha. Let's leave cos alpha as it is. Cos alpha multiplied by sine alpha over 2 divided by cos alpha over 2 minus b sine alpha over 2 over cos alpha over 2 minus c multiplied by sine alpha over 2 sine alpha over 2 multiplied by cos alpha over 2. And this is minus bc sine alpha over 2. So that's 2 sine alpha over 2 cos alpha over 2. So sine alpha over 2 cancels. Okay. Kind of useful. Now multiply everything by cos alpha over 2. So x by c multiplied by cos alpha minus b minus 2c cos squared alpha over 2 equals minus bc 2 cos squared alpha over 2. Actually we might get some place, might get places. And cos squared alpha over 2 can be expressed as cos squared alpha over 2 can be written as minus 1/2 multiplied by 1 plus cos alpha, if I'm not mistaken. 2, yes. Okay. And I can x c cos alpha minus b minus 2c multiplied by 1/2 multiplied by 1 plus cos alpha and equals minus bc multiplied by 2 multiplied by 1/2 multiplied by 1 plus cos alpha. Interesting. So x c cos alpha minus b minus, so 2 cancels, c minus c cos alpha, ooh, spooky, equals, so 2 cancels, minus bc minus bc cos alpha. Right, finally, x is equal to bc plus bc cos alpha divided by b plus c, which is bc, open bracket, 1 plus cos alpha, divided by b plus c. As I said, close your eyes, hope for the best, and and perhaps it will take you somewhere. So yeah, we found x, and now we need to find y, which is very simple actually, because we have, this is the x coordinate of m. Now x coordinate of y, because we know the equation of the line AM. So now y is equal to tan alpha over 2 multiplied by x, and x is bc 1 plus cos alpha divided by b plus c. Okay. Can we do something about it? Well, we can. We can say that this is equal to tan alpha over 2 multiplied by bc multiplied by, so this is 1 plus 2 cos squared alpha over 2 minus 1. Ooh, lovely. Divided by b plus c. So y is equal to tan alpha over 2 multiplied by bc multiplied by 2 cos squared alpha over 2 all over b plus c. And that's equal to, so it cancels with this, and this becomes sine alpha over 2. And this becomes bc multiplied by sine alpha b plus c. Okay, a lot of trig here, somewhat unexpected, but yeah. So now you found the coordinates. You found the coordinates of m, and the coordinates of m are, so bc 1 plus cos alpha over b plus c, comma bc multiplied by sine alpha b plus c. And you need to find the length. So the length is given by, so am is the modulus of the vector, so it's the square root of bc 1 plus cos alpha over b plus c squared plus bc multiplied by sine alpha over b plus c squared. It looks scary, but it isn't, because a lot of stuff just comes out of the square root. So, and this is bc can be taken out over b plus c, and we're left with 1 squared plus 2 cos alpha plus cos alpha squared plus sine squared alpha. So am is equal to bc over b plus c square root. So that is 2 plus 2 cos alpha, 2 plus 2 cos alpha. So yeah, we have length of am is equal to square root of 2 bc divided by b plus c square root 1 plus cos alpha. 1 plus cos alpha, of course, square root of 2 bc, b plus c multiplied by 1 plus cos alpha over 2. So that is 1 plus 2 cos squared alpha over 2 minus 1. Minus 1 cancels. Ooh, 2 it goes 2 bc over b plus c multiplied by cos alpha over 2. That's a beautiful answer for such a horrible question. All right, so apologies for taking ages with this, but the answer is am is 2 bc b plus c multiplied by cos alpha over 2. Okay, a question with the y coordinate. No, because it cancelled. It's cancelled. The cos alpha over 2 cancelled with the cos squared alpha over 2. So the question is, should be there cos alpha over 2 in the numerator? But I have 1 plus cos alpha. There's no cos alpha over 2. For the y coordinate. In the numerator, it's sine alpha over 2 times 2 cos alpha over 2. So that's 2. All right, I'll explain how I got there. So it's BC multiplied by 2 multiplied by sine alpha over 2 multiplied by cos alpha over 2, which is sine alpha. BC multiplied by sine alpha over B plus C. Does that make sense? Okay. On a scale of 0 to 10, if I give you the exact same problem right now, do you think you would be able to solve it? On a scale of 0 to 10, if I give you the exact same problem, do you think you'd be able to solve it? Ooh, nice. Yeah. Okay. Apologies. Something, well, it's really not something I was looking forward to. Not something I wasn't looking forward to at all. Okay. All right, it's back. It's back online. Okay, so equation of a straight line in 3D. Does anyone know how to do an equation of a straight line in 3D? What does an equation of a straight line in 3D looks like? I was sure I would had it here, but anyways. Equation of a straight line in 3D. It's tempting to assume, so for example, yeah, it looks like, because the equation of a straight line in 2D can be written as mx plus b, or plus c, sorry, C, and it can be rewritten as ax plus by plus c equals 0. Or how did you put it? Yeah. It is very tempting to assume that this is a straight line in 2D. It's very tempting to assume ax plus by plus cz plus d equals 0 is a straight line in 3D. It's very tempting. Ooh, Caden, very well done. The maths assignment will be out tomorrow. Okay, the assignment 6 will be out tomorrow, but you can access assignment 6 via this link. This is a draft version, but the problems will not change. Okay, and it's here. So this is the assignment. So you can start today if you're desperate to start today. But quick view will tell you that in fact this is not true. Do we have 3D? Does Desmos have 3D? I forgot. I know GeoGebra has 3D, definitely. Yeah, let's go to GeoGebra. Okay, so this is 3D. And if I type in y equals, let's say x, oh, what am I doing? X plus y plus 2y minus 3z equals 4. You can see that it is not a straight line, but in fact, it is a plane. It is a plane in 3D. 3D. So not a straight line. Yeah, I saw the beta, yes. Oh. No, that's not it. The link is here. Okay. Here's the link. Now, if you want a straight line, then you need to understand something. So how does a straight line work? Well, let's say you have a straight line and you know the position vector. Remember the position vector. Let's say this is the origin. And this is a position vector of a point on the line. A is some fixed point on the line. Point B has coordinates x. Well, no, just point B. Point B is another point on the line. Right. Okay. So we call vector OA is the position vector of some point on the line. So let's not use R0. Can we use R0? Yeah, we can use R0. Why not? And vector AB we call the direction vector. Once again, we want to find the equation of line AB. Vector OA is R0. OA is R0, is the position vector of point A. AB is the direction vector of the line. Now, the position vector of any point on the line, then this is tough. The position vector of any point on the line is R, which is equal to OA plus, well, R is equal to R0, is this vector, plus lambda A. Okay, sorry, I might have confused you. Let's call this B, and this vector A. If we multiply the vector A by lambda, we get vector AX. I really don't want to confuse you too much. Sorry. I'll delete this. So, okay. A, which is also AB, is a vector parallel to the line AB, which is known, A is called the direction vector. Vector AX, which is equal to lambda multiplied by A. So AX is just a longer version of AB. Does that make sense? But AX is a longer version of AB, so it's just a longer vector. It's extended. Now, if we add vector OA, So vector OX is equal to OA plus AX. Well, that should be obvious, right? OX is OA plus AX. That should be fine. And what do we have now? We have that OX is the R, and it's equal to R0 plus lambda A. And this is known as the vector equation of a straight line. Vector equation of a straight line. How does that work? I understand it might be tough for you right now because I mean it's you haven't done this. This is year 13. This is year 13 stuff. Yeah, it does, of course. But let's see if it works. Let's see if it works. Let's try to draw a vector form of some easy line. So let's say we are in 2D, X and Y, and we have a line like this. This is 1. This is 1. So can somebody give me the equation of this line? X, it's not, it's 1/2 x plus 1. X plus 1. Okay, 1/2 x plus 1. This is what we are looking for. This is the equation that we know, but that's the Cartesian equation. That's the slope-intercept form. To find the vector equation, we need to find any vector on this line. So for simplicity, I'm going to use this vector. And this vector A has coordinates 2, 1, 2, 1. We need the position vector of any point on the line. Well, let's take this position vector. Well, okay, let's not reinvent the wheel. Just this position vector. So this vector R0 is 2, 2. So the equation R is equal to R0 plus lambda multiplied by A. How does that work? Well, it's vector R is equal to 2, 2 plus lambda multiplied by 2, 1. So we take any point on the line plus any vector parallel to the line. And now we can, but R is xy. So xy is 2, 2 plus lambda 2, 1. And from here, I get x is equal to 2 plus 2 lambda, and y is equal to 2 plus lambda. So from here, I can express lambda is equal to x minus 2 over 2. And here I can say lambda is y minus 2. Now I can equate those sides, both sides, lambda, because they're both equal to lambda. So x minus 2 over 2 equals y minus 2. So y is equal to 2 plus x minus 2 over 2, which is 2 plus x over 2 minus 1, which is x over 2 minus 1. So y is x minus 2 over 1. Do you see how that works? To get the vector, this is a vector equation of the line. It's super important. And I think we did this in physics in the first assignment. X over 2 plus 1, of course. Yes, thank you. Plus 1. You take any line parallel, you take any point on the line, you take any vector parallel to the line, and you write this down like this. And this gives you the vector equation. So that does mean that you can have more than one different vector equation for the same line, but that's also true because you can have infinitely many equations for the for any line. Is that making sense? That comes from rearranging the 3D vectors. Anything. That's the thing. That's the beautiful thing about it. You don't. You can take two different lines. You can say, okay, as R0, I can use any point on the line. I can use, for example, this one, 0, 1. So R0 is 0, 1. And as the vector parallel, I can use this one, minus 2, minus 4, minus 2. And A is minus 4, minus 2. The equation becomes R is equal to 0, 1 plus lambda multiplied by minus 4, minus 2. It's the equation of the same line. Let's see if I can do that. I certainly can, Desmos. I can do that. X is 0 minus 4 lambda. 0 minus 4. I'm going to use t. And this one, 1 minus 2 lambda. 1 minus 2 t. Doesn't like it? Oh, it's round brackets. No. And t is from minus 10 to plus 10. Here it is. Here's a straight line. Now I'm going to draw another one. What was the other one? The other one was x is 2 plus 2 lambda. So 2 plus 2t, comma, 2 plus 1t. 2 plus t. Minus 10. 10. What? Look at that. They're the same line. Even though they're written differently, but it's the equation of the same line. So you have more than, can have different equations. Now in 3D, it's the same thing. You choose to get to obtain an equation. So let's say you're in 3D and you have a line in 3D, line L passes through point 1, 2, 3, parallel to the vector a, let's make it 1, -1, 2. So you write down the equation of the line. R is equal to R0, so it's 1, 2, 3, plus lambda multiplied by a, which is 1 - 1, 2. This is an equation of a line. Let's see if we can do that. R is equal to 1, 2, 3, plus t multiplied by, what was it? 1 - 1, 2. 1 - 1, 2. Doesn't like it. T. Mm. Okay, so what do you need to understand here? So if you, I'm not sure how to do this. Not sure how to change the parameter, but t is a parameter. T is like time. Yeah, so lambda is like time in this equation. So when lambda is 0, the point is 1, 2, 3. When lambda is 1, for example, it's going to be 2, 1, 5. So let's see what happens if I change t. So if I make t 0 plus 0, you can see this is the initial point. This is the position vector of the point, so it's here. If I change this to 1, why is it not changing? Okay, 0, 1, 2. You need to press enter. Okay, enter. If it's 0, it's here. If it's 1, it's here. If it's 2, it's here. So it's moving along. You can see that. You can see it's shifting. So you have the point, this black vector draws a straight line over here. Okay. And we can convert this to an equation of a in Cartesian form. So from here, we can write x is equal to 1 plus lambda, y is 2 minus lambda, and z is equal to 3 plus 2 lambda. And from here, I can express lambda is equal to x minus 1. Lambda is equal to 2 minus y, and lambda is equal to z minus 3 over 2. And because it's all equal to lambda, we can express it as x minus y minus 1 equals 2 minus y equals z minus 3 over 2. And this is the Cartesian equation. Cartesian equation. And this is the vector equation. Vector equation. Okay, so let's have a look. If I can write the Cartesian equation, it's going to be x minus 1, 2 minus y. X minus 1 equals 2 minus y equals z minus 3 over 2 equals z minus 3 over 2 times 3. Doesn't like it. Let's see if we have better luck with Desmos. X minus 1 equals 2 minus y equals z minus 3 minus 2. Oh no, z minus 3 over 2, is it? Over 2. Yeah, z minus 3 over 2. Okay. Yeah, we got better luck with Desmos. So you can see this is a straight line, indeed. And if we draw a vector, r equals 1, 2, 3 plus t multiplied by 1 minus 1, 2, 1 minus 1, 2. And it doesn't like vectors. Okay, let's see if we can do this. X, Y, Z. Doesn't like it. Anyways, we've got a straight line. And if you, as you change the vector, if you change the value of lambda, if you do it here, so what happens is if the vector r, the crucial one, so vector r, so if it's 1, it changes like this. So vector r, if lambda is 0, this is vector r if lambda is 1, this is lambda equals 2, lambda equals 3. etc. So I hope that makes sense. I hope I haven't lost you and haven't yeah. Equation of a plane in 3D and the distance between the plane and a point. You will please read that in the assignment, because it will take me quite a while to go through. I don't want to get stuck as with the straight line. I hope that was useful. But don't worry if you don't get it from the first attempt. Yeah, it needs time to sink in. So don't worry if you didn't get it. Okay, so prove that ABC is a right angle triangle. This is an easy question, honestly, very easy. You have 3 points in 3D, so A, B, and C. How would you prove that triangle ABC is a right angle triangle? How would you go about it? Agastya. Too easy for you. 6 minus 4, 2. 3, 2, 3. And C is 3 minus 5 minus 1. Very good. Yes, you find the vector. So if the triangle is right angled, that means either AB multiplied by BC is 0, or BC multiplied by AC is 0, or what's the third option? AB times AC is 0. So one of the three. One of the three. And all we need to do is find vectors A, B, and C. AB is minus 3, minus 6, 1. BC, vector BC is 0, minus 7, minus 4. And AC is 3 minus 6, so minus 3. Minus 5 plus 4 is minus 1. Minus 1 minus 2 is minus 3. And now we check the dot products. So AB multiplied by BC is equal to minus 3 times 0 plus minus 6 times minus 7 plus 1 times minus 4. That's not equal to 0. I don't even need to calculate it, but it's not equal to 0. A B times AC. AB times AC, and that is minus 3 times minus 3 plus minus 6 times minus 1 plus 1 times minus 3, and that's equal to 9 plus 6 minus 3 is not equal to 0. Ooh, I hope I didn't make a mistake. It did seem like it's going to be 0, but in the end it didn't. Then BC times AC. Okay, BC times AC. 0 times... Oh, I think I'm in trouble here, because this isn't 0 either. Where did I go wrong? And it might be I went wrong when copying the question. 6 minus 4, 2. 3, 2, 3. 3 minus 5 minus 1. Okay, I copied it correctly. AB is, okay, AB is minus 3, 6. Yes, that's where I went wrong. So this is plus 6, this is plus 6. So that's minus 6, and that is indeed equal to 0. Whereas BC times AC is not equal to 0, which makes perfect sense. And that means that AB is perpendicular to AC. Therefore, A is a right angle. This angle is 90 degrees. Not drawn to scale, of course. Therefore, angle A is 90 degrees. Yay. Okay. The next question. ABCD A1, B1, C1, D1 is a cube, and M is the midpoint of CC1. Find the angle between DA and DA1 and DM. Well, it always comes down to drawing a decent diagram. So let's see what we can do here. So the standard way of writing is that this is the x-axis, this is the y-axis, and this is the z-axis. This is a really good practice. Then you have ABCD. So we're looking for the angle between DA and DM. So which point would you put into the origin? Yeah, D. We point D into the origin. So let's call it A. B. A, B, C, D, because why not? And then if this is D1, this is A1, this is B1, and this is C1. All right, with some color. Assume that's the length of the side is A. Assume side, this is not the side, the edge is A. So we can find the coordinates. This is 0, 0, 0. This is X, this is Y, and this is Z, of course. So which points do we need? Well, we need D, or D is 0, 0, 0. A1 is, well, it is 0, A. DM, M is the midpoint of CC1, so we need C. C is A0, 0, because it's A on the X side, 0 on Y, 0 on Z. C1 is going to be A 0A and point M is halfway. So it's A 0 A over 2. And then it becomes really simple, because all we need to do is find the vectors, the vectors in question. DA, DA1, and DM. So DA1, vector DA1 is going to be 0 minus 0, so that's 0. A minus 1, so it's A. And DM is A minus 0, so it's A, 0, A over 2. And to find the angle, we need to remember the cos, the dot product. Remember that dA, well, A multiplied by B is modulus A, modulus B, multiplied by cosine of the angle between the two vectors. So if you want the cosine between two vectors, of the angle between two vectors, you need the dot product of the two vectors divided by modulus A multiplied by modulus B. So in this particular case, you need the cosine of angle A1 of the angle A1DM, because that's the angle in question. We are looking for this angle, theta, and that's equal to dA1 multiplied by dm divided by the square root of what? No, not the square root, is divided by dA1 modulus multiplied by dm modulus. And so dA1 is this, so it's going to be 0 multiplied by A plus A multiplied by 0 plus A multiplied by A over 2. That's the dot product of the two vectors. And here we have the square root. So this is the square root of 0 squared plus A squared plus A squared multiplied by the square root of A squared plus 0 squared plus A over 2 squared. So this is 0, 0. This is A squared over 2 divided by, this is 2 square root of 2A, if you simplify this. And this becomes A squared plus A squared over 4. That is 4 plus A, that's 5 A squared over 4. Does that sound right? 4 plus 1, 5. Yes. Under the square root, this is A squared over 2 divided by square root of 2A multiplied by square root of 5 multiplied by A over 2. 2 cancels, A squared cancels, and we get 1 over square root of 10. So cosine of the angle theta is square root of 10 over 10. So the angle in question is approximately cosine, the arc cos. That's arc cos square root of 10 over 10. Should be quite large, so it should be about 80 degrees. Let's see if arc cos square root 10 over 10, 71.6 degrees, 0.6 degrees. So you see how a question which would probably be impossible if you well, not impossible. You could always find the length of the sides and use the cosine rule, of course. You could use the cosine rule here. But see how easy it becomes when you are doing it in vectors. All you need to do is just remember the formulas. And the formulas are here, like in the assignment. So if you the distance between 2 points, the equation of a line passing through a point, the formula for the plane, the distance between a point and a plane, and yeah, cosine of the angle between two vectors, cosine of the angle between two planes. Very useful, some very useful stuff. If you are doing any sort of, I don't know, computer games, for example, all the modeling is done using vectors. The last thing, I don't have enough time to finish it, but what happens is find the radius of the sphere. So we have a cube. Find the radius of the sphere passing through A, B. So passing through A, B1, E, and F. So there's a sphere which we don't know how it looks like, but we know that it passes through these 4 points. And there's only one sphere that can pass through 4 points, right? So if you have 4 points, there's only one sphere passing through. Okay, so what we need is to find what we need to do is we need to assume that O, let's say O, with coordinates x, y, and z, assume O with coordinates x, y, and z is the center of the sphere. Center of sphere. That means that OA is the radius, OB is the radius, OB1 is the radius, OF is the radius, and OE is the radius. That means that OA is equal to OE is equal to OF equals to OB1. And by writing down the length of OA, because you know the formula for the distance between 2 points, you have 3 equations with 3 unknowns. And that's it. Three equations with 3 unknowns, and that's it. Fantastic. Lovely. All right, then this allows you to find x, y, and z, and that allows you to find the radius as well, which is equal to the radius of the sphere. All right, I hope this was useful to you. I hope you didn't lose me with the equation of a straight line. Do explore in detail the equation of a straight line in 3D. It's a really nice topic. I find it very elegant and incredibly useful in practical applications. All right. Okay. Then I'll see you next week. Okay. There was a question. Welcome. I have a quick question related to friction. We've been doing forces in physics. There is a question. I've had a question about friction. We've been doing forces in physics in school, and the question came up on how we could reduce a cyclist's friction. In one of the webinars, we had concluded that friction doesn't depend on the surface area in contact. But my teacher said it does, because if you reduce the width of the wheel, the friction would be reduced as you have a different mu. He said that mu takes care of factors like surface area and surface area and contact. So is that really how it works? In the real world, the mu depends on the contact area. Yes. Because if you look at the wheels of a Formula One car, they're very wide wheels. And any Formula One driver will tell you that you need wide wheels for more grip. But according to the physics model, that the friction is mu n, mu times the reaction force, the surface area is not a factor. The reason is because we use a simplified model. Okay, in the real world, the friction does depend on the surface area. Although this dependence is not, it's not massive. So we can ignore the fact that increasing the surface area, the contact surface area will increasing the surface area will change mu. We can ignore that for simplicity. Okay. Does that make sense? Yeah. But generally speaking, like Formula One is an extreme case, because if you take a simple experiment, you take a rectangular block, like a box. Take a rectangular box, put it like this, measure friction. Then put it like this and measure friction. You will see that they are very close. Even though the surface areas are very different, you would see that the values are very close. Okay. All right. See you all.